When we look at this rational expression, the first thing we should notice is that the numerator is 1 degree higher than the denominator. That indicates that we have a slant asymptote for this, okay, or potentially a slant asymptote. So we should first factor to see if there's any common factors that cancel. In this case, I factor this and there are no common factors. This also allows us to generate zeros for this expression. So we know we have a zero at -2. We have a zero at +1. And we have at 3, just going to do this in a different color here. At x equals 3, we have a vertical asymptote. Okay, so that's going to generate our vertical asymptote. And these give us the zeros of the function. So I'm going to just plot those zeros. So at x equals -2, so this looks like it's going to be right about here. And at x equals +1, maybe about here, we have zeros. And if we plug in the y is 0, we can see that at y is 0, we're going to get a value of 2/3. Okay, so that is some coordinate that we may want to plot. It's a little bit hard to plot on this scale. Okay, once we've done this, we want to see what the slant asymptote of this is. So we're going to do some long division. Okay, so from long division, we're going to end up dividing x minus 3 into x squared plus x minus 2. So we end up with x. We end up with +4. So we end up with this, and we end up with a remainder of +10. Okay, so this case here, our slant asymptote then is going to be 4x plus 3. So we have a y-intercept at 4, somewhere around here, and we're going to have a slope of 1. So draw the slope 1. I'm just going to plug in x is 20, y is going to be 24. So it looks like somewhere up here. And x is -20, y is going to be -16, somewhere around here. Okay, so then drawing in our slant asymptote, it's going to go through something like that. Okay, so that's what the graph looks like. We have to put in our vertical asymptote at x equals 3. So at x equals 3, we have our vertical asymptote coming through here. Okay, and then we can find our derivatives to locate our min and max points. So our derivative, I'm going to do the derivative in red here. So the derivative, when we differentiate this, so f prime, differentiating the numerator, I get 2x plus 1 times x minus 3 minus, we end up with x squared plus x minus 2 times 1. All over the denominator, x minus 3 all squared. So we want to simplify this expression. So we end up with 2x squared. We end up with -6 plus 1, so -5x minus 3 minus x squared minus x plus 2. Okay, so we end up with, in this case here, simplifying this, x squared minus 6x minus 1 in the numerator. And then in the denominator, we end up with x minus 3 all squared. Okay, so we want to find out where this is equal to 0. So we need to use a quadratic formula. So x is equal to 6 plus minus square root 36 minus 4 times a times c, which is -1, all over 2a. Sorry, 2a is 1, so just 2. So simplifying this, we get x is equal to plus 6 plus minus square root of 40 over 2. And this simplifies to 3 plus minus. The 4 comes out outside, becomes 2. That cancels with the divide by 2. So we get 3 plus minus root 10. Okay, so in our denominator here, we have our at 3 plus root 10, that's about 6.2, so somewhere around here. We have a 0 slope. Okay, we have an undefined slope at 3. So that's going to be 3 plus root 10. Okay, at 3 minus root 10, that's going to be about negative 0.2. So that's going to write that 3 minus root 10. And then there's our 0 slope here. And we should test our slopes in here. We can probably predict what the slope looks like because we know that the graph is going to look something like this. It's going to go follow the asymptote. It's going to go up through there. We're going to have a max somewhere in there, and it's going to follow the asymptote down like this. Okay, so we know at this point we should have, on this section, we should have positive, negative, negative, positive, like that. Okay, we should just confirm this though. We should test some points. So f prime at negative 1, we put negative 1 into that, we end up with positive slope. F prime at 0, if I plug in 0 in there, the numerator is negative, the denominator is always positive, so we end up with negative. So we have positive slope through here, 0, we have negative slope through here. F prime, and we want between 3 and 6, so we're going to maybe choose 4, so f prime at 4. We end up with, in this case, it's going to be 16 minus 24 minus 1, so it's going to be negative again. So we're going to have negative slope through here. That's going to mean that's a minimum. And f prime at, let's just plug in 7. So we're going to end up with positive slope when we plug it into that expression. Okay, so we have positive slope here. So there's our slope chart. And using the slope chart, we can see the x-coordinate of the minimum and maximum is going to be at negative 3 root 10, minus root 10 and positive 3. So it's going to be not negative 3, it's going to be 3 minus root 10 and 3 plus root 10. And so when we draw that in, the graph is going to be somewhere around, if I estimate just when x is 6, just to get an idea what that max coordinate is. We don't need the y coordinate, but I just want to see what that we're about to draw this. So I get 36 plus 6 is 42 minus 2, so that's 40 over 6 minus 3, so 40 over 3. That's about 13 and a bit. Okay, so at 6 and 13 and a bit, somewhere around here, that's going to be, we're close to where the minimum point on the graph is going to be. So it's going to come through like this and then follow the asymptote through here. Okay, so those are our, and I'm just going to highlight those points here. So that's going to be at 3 plus root 10, and that point here is going to be at 3 minus root 10 as the x-coordinates of those min and max points.